Hi everyone, we are going to make a circuit with two resistors in series. As you can see in the diagram here, these are the two resistors, and here is my power pack and my ammeter and the voltmeter and two resistors here. And in red line we can see the two resistors and an ammeter are connected to the power pack as in a separate loop. Then in blue wires we can see a voltmeter is connected to the main loop as a separate loop. So we all know an ammeter is connected to a circuit in series and a voltmeter is connected in parallel way. So now we are going to build up this circuit with the power pack, and here is my ammeter and a voltmeter, and I need some leads, and these are my two resistors, and I need some crocodile clips. So starting with the power pack, I'm going to connect power pack into the ammeter, then get another wire coming from the ammeter, other end of the ammeter, and I'm going to connect that into the one of my crocodile clips. Then it is joined with the one of my resistors, and then I'm going to have another lead to join these two resistors together. I need another crocodile clip to fasten that, and then I have my another lead here, red one. Then I'm coming back to the power pack and joining here. So you can see we have connected the main loop, that is in red, the power pack and one of my resistors, the second resistor, and it is going to the ammeter, then joining with the power pack. So these are all connected in one loop in series. So now it is time to connect my voltmeter to the circuit in a separate loop. I am using two blue leads as shown in the diagram. I'll get it here and connecting one end of with the one loop, one wire, and then I'm taking the left wire that is connected to the left hand terminal of the voltmeter, and I'm connecting here the left corner of the resistor, and getting the other wire, the blue one, is connecting to the other end of the second resistor. Now you all can see this voltmeter is connected in a separate loop, as in parallel way. You can see the voltmeter is connected the either side of the both resistors, not just with one resistor. So we are going to measure the voltage in between both resistors. So I'm going to get this voltmeter to the front so you will be able to see the readings clearly. So now it is time to switch the power supply on. I'm going to start the voltmeter and the ammeter here, and the power supply is on. So we can see the readings on the meters. So we are going to use these numbers to get the total resistance of this circuit by using Ohm's law equation, which is V equal IR, and then R is given by dividing V value by I. So here I'm going to substitute these numbers: 3.29 volts divided by 0.17 amp. So I'm going to use my calculator here. 3.29 is divided by 0.17, which will give us 19.35 ohms. And actually the resistors are unique and they have got a value of 10 ohms. So by looking at our numbers, we can see they are not exactly 20 ohms, but approximately 20. So we can come to a conclusion: if we add two resistors of 10 ohms in series, we will get 20 ohms in as a total resistance. So we can come to a conclusion: when you add two resistors, the total resistance of the circuit is doubling up, or you can add them up together. And now it is time to see if we add another resistance into the circuit to make altogether 3 resistors in series. So I am going to add one more resistor here, joining with 2 crocodile clips. It is easy, and the other end also is also connected to this crocodile clip. And I'm going to get a red lead and then joining together here. So now you can see I'm going to take this board away, and you can see we have 3, my first resistor, the second and the third. These all are in red lines as a main circuit, and then here is my voltmeter that is connected to the resistors. The voltmeter will give us the total voltage in between these 3 resistors. So now I am going to switch the meters on so we can see the numbers. Now I am going to use Ohm's law equation again. V equal I R, then we get R by dividing V by I, and here V value is 3.26, then I value is 0.11. I am going to substitute these numbers again onto my calculator. 3.26 is divided by 0.11. We get 29. We get the value of 29.63 ohms. So we can see it is also nearly to 30 ohms. As we know, we had 3 resistors of 10 ohm, so we got the total resistor by using the Ohm's law equation, approximately 30. So we can come to a conclusion here: when you add up resistors in series to a parallel circuit, then you will get the total resistance as the sum of each resistors. You can add them up and get the total resistance when they are connected in series to a circuit. I hope you understood how to build up a circuit with resistors in series and how to use the Ohm's law equation to calculate the total resistance of any circuit. that are connected in series. Thank you so much for watching.